Hello everyone, and welcome to probably the easiest chapter in this entire textbook. Centroids and centers of gravity. Now, there is not a lot here in text. It's a very short chapter. However, I'm still going to give you a week in it because you probably need that to catch up in other weeks. Either way, we're here. Let's focus on it and see what it tells us. Well, what you all know is that you have a weight. If you get on the scale, you're going to see that. But where does that weight come from? Well, weight is gravity pulling on your mass. It pulls you down. But if you think about it, you're made up of a bunch of different atoms. And so technically, it's each of those individual atoms which is being pulled down. And it's just the sum, the algebraic sum, that becomes your weight. Now, it seems silly to think about that with you, but what about with a car? A car has a whole lot of parts, each with their own weight. And it would be obnoxious if we were trying to figure out how the car is working to simulate each of the weights individually. And so what we do is we look for this point called the center of gravity. The center of gravity is where, effectively, for most practical purposes, all of the forces of gravity, all of your weight goes through this point. It's very much like the resultant of we had all those forces on a beam, and we said, okay, there's 5 forces, but I can find one force placed at a certain point that's the same as all of them. Same thing here. We find that one point where if we apply our weight, it's the same as if we applied it to the entire body. So how do you calculate that? Well, your weight is simply the sum of all the weights for the objects. You might have multiple objects that are welded together and they each have their own weight. And so you'll have to add all those together. And then you're going to be doing something that's very similar to what we did when we were trying to find the resultant vector. Actually, it has the exact same form. So you're going to take here a sum of all of the weights times their position along the x-axis. And that's going to be equal to the total weight times the centroid's location in the x direction. Just like with our resultant vector. And the same thing for the y-axis. So if I want to, what I can do is I can find that my center of gravity is going to be equal to all of my weights, many weights, times their position, over the sum of my weight. It's this more or less weighted average. What we're going to find is that this is good for pretty much everything. This equation, it just doesn't go away. You're going to see it over and over and over and over and over again. And so here's how it might look. Now this is for a kind of amorphous body, but it might be that you just have something like this. That you have a hammer where it's got a handle and it's got its own weight. And the hammer's head has a weight. And you would want to figure out, well, what is the center of gravity for that? And you could use our equation to figure it out. And since the hammer head's probably much heavier, it's going to be closer to this than this other one because it's a weighted average. Okay, what about the centroid? Well, centroid is 2D. Before it was 3D. This is 2-dimensional now because we're only looking at an area rather than something that has a mass. But otherwise, our equation is exactly the same. If I'm trying to find the centroid of a shape, let's say this rectangle with a circle element, then I would look for where the center of that circle is, and look for where the center of that rectangle is, and I could use this equation then to solve for it. It's that simple weighted average equation. I take the sum of each of the areas times their personal centroid over the total area. And that will give me the location of the overall centroid. So if you did fairly well when we were talking about the resultant of a bunch of forces acting on a beam, this should make a lot of sense to you. It should be fairly easy. So how do we do this? Well, if we're trying to find the center of gravity or the centroid, more or less the same, you're going to sketch the members showing all of your dimensions. And you want to find any axis of symmetry because if there's an axis of symmetry, like where it's the same on both sides, it looks like we got a shampoo bottle like this. It's a terrible thing. Imagine it's symmetrical, along this axis. And our centroid is going to be somewhere on that axis. You're then going to divide the member into component parts. It might look complex, however, it is not all that complex. It's actually made of a bunch of simple shapes. And then you're going to choose your origin, say where it's coming from, and they're going to use the equation we just solved for centroid and for center of gravity to solve. Tables are super helpful in these kind of instances, especially if you've got several different shapes, and I will definitely show you some examples of that later. Okay, now what if you had a crazy structural member? Not all these are crazy, like this one right here. That's not too bad. What about the pipe, or this C shape, or this L shape, or this timber? I mean, the timber is not terrible, but this C shape right here, you see these roundings, and the L shape, like well, it's a nice perfect L right here, which I make into like 2 rectangles. It could also be rounded, which would not be nice. Or rounded in here. There's all these fillets that usually come into play here. So for structural members, you don't try to calculate it by hand. Instead, you will go to your appendices in your book. In fact, for these types, there's actually an appendix for each of these. Appendices A through E. So if you see a problem that has a special shape, and it will give you some designation for it, then you will go to your appendix at the end of your textbook, and you will find its centroid and its center of gravity, and everything else you need from that appendix. Okay, that's it. That's literally everything you have to learn in this chapter. All the equations, all the talking, that's all done. So what I'm going to do is I'm going to go through several of the example problems, just talking to you about all the steps they take and why they take them. And then I'm also going to give you some example videos. I know the example videos, I'm going to be showing you example videos as part of these. But, I mean, honestly, with this being such a short chapter, you're going to get some extra ones. Some of those are going to be more like book problems. Other ones are going to just be the examples in your book. Okay, so thank you for listening, and I'll see you all next time.